Hello everyone, welcome back to our class. We are now in our week 4, lesson 4, sound energy. Our most essential learning competency for this week, we are going to investigate the effect of temperature to the speed of sound. Our lesson objectives are: number 1, compare the speed of sound to solid, liquid, and gas. Number 2, determine how temperature affects the speed of sound. Number 3, describe how the speed of sound in air can be measured. And number 4, observe how sound waves reflect and refract. Every day, we always hear different sounds. This can be music that we love to hear or random sounds coming from different voices, noise from vehicles or from different musical instruments, and many more. Sounds can be an outlet to release our stress and gives us some sort of relaxation. Today, class, we will explore the nature of sound and its characteristics, and let us find out the effect of temperature to the speed of sound. Sound waves are examples of longitudinal waves. Like other waves, they also exhibit characteristics, features such as frequency, amplitude, wavelength, period, and wave speed. Just like what you have learned during grade 7, waves have crests and troughs. But in longitudinal wave, they are synonymous to compressions and rarefactions. These compressions and rarefactions are created when the particles of the medium are alternately push and hold. Let us begin our discussion on how sounds are propagated. Sounds are propagated through vibrations. Sound can be produced when you tap or hit objects that cause them to vibrate. For example, when you hit the drum, the surface vibrates, that cause to propagate or produce sound. Vibrations occurs in the drum. Same with the guitar. As we play the guitar, the vibrations of the string release sounds, and as long as the string vibrates, it will produce sounds. How sound travels? We have to emphasize that sound is a kind of mechanical wave. That means that the sound needs a medium to travel. For us to travel, we need vehicles to send us in our destinations. Same thing with the sound. Sound needs a medium to travel and to transfer from one place to another. These mediums can be solid, liquid, or gas. For us to know which medium the sounds travel fastest, we have to know the molecular structures or arrangement of solid, liquid, and gas. In solid, notice that the molecules are very close to each other while vibrating. In liquid, molecules, they have spaces enough for the particles to move. In gas, particles, they have the most distance that makes them to move freely. Based on the molecular structures of solid, liquid, and gas, which medium will sound travel fastest? Is it in solid, liquid, or in gas? You are correct if your answer is solid. Sound travels or transfers fastest in solid because particles are very close and easy to transfer vibrations of sounds. Next is liquid, and the slowest is gas. There are also factors affecting the speed of sound. We have medium's elasticity, medium's density, and the temperature. Sound travels faster on objects with higher elasticity, like most of the objects. Sound travels faster on less dense objects. How does the temperature of sound or the medium affect the speed of sound? We have said earlier that particles are constantly moving. It means that regardless of the medium, particles move constantly. Last week, we discussed kinetic energy of moving objects. Remember that kinetic energy of particles are affected by temperature. A medium with high temperature gains more kinetic energy that makes the particles move faster. And when a medium with low temperature, the molecular kinetic energy moves slower. It means that the higher the temperature, the fastest the movement of the particles. Now, how can we relate this concept to the speed of sound? Since sound needs a medium, its speed depends on the speed of particles where sound used to travel or transfer. If the temperature increases the movement of particles, it also increases the speed of sound. But when the temperature decreases, the speed of sound will also decrease. Properties of waves, such as reflections and refraction, are also evident in sound waves. Reflection of sound. The bouncing back of sound. It includes echo, the reflected sound, and reverberation. Multiple reflections of sounds, as we hear when we are in bathroom singing. Measuring the speed of sound using echoes. First, we have to measure the distance between the man that will produce claps to the wall. Let's say that it is 100 meters and get a times ready. When he claps, the sound waves of the claps that travels toward the wall and gets reflected on the wall and then travels back toward us so that we can hear the echo. Thus, the speed of sound is equal to, speed is equal to 2 times d divided by time. D stands for distance and t stands for time. So speed is equal to 2 times 100 meter divided by 10 seconds. Velocity is equal to 2 times 100 meter divided by 10 seconds is equal to 20 meter per seconds. Refractions of sound. The bending of sound waves. Sound refracts as they pass from one medium to another, solid, liquid, or gas. During the day, the sun heats up the Earth's surface, warming the air close to the ground. Sound travels faster in a warmer air, so the sound travels faster in the air close to the ground. The reverse happens at night. At night, the ground cools quickly. The higher air is warmer than the air close to the ground. During the day, the sound travels faster near ground. This causes the sound wave to refract outward. At night, the opposite happens. The sound further from the ground travels faster at night, causing the sound wave to refract back towards the earth. This applies why concert held at night for the viewers easy to hear the sound even far away. Now let us have our recap. The speed of sound may differ for different types of solid, liquid, and gases. Sound waves travel faster in solid than in liquids and faster in liquids than in gases. Sound can travel faster in medium with higher elastic properties than in lower elastic properties. And finally, the speed of sound is directly affected by the temperature of the medium. Now you may answer your learning tasks in your module for this week for you to measure your understanding regarding our lesson. Thank you.